So hello everyone, let us solve another LeetCode problem, and the problem name is search in rotated sorted array. So let us read the problem statement first. So there is an integer array nums sorted in ascending order with all values being distinct. Now prior to being passed it to your function, the nums was possibly rotated, and then they have given the entire explanation how it was rotated and all that. After that they are saying that given array nums after possible rotations and an integer target, you need to return the index of the target if it is present in nums, and if it is not present you need to return -1. So, and they've also said that you need to complete this entire function to run in log of n time. So what does this question mean? So question is simple, like it is nothing. So initially they are saying that this is a kind of sorted array, and they have just rotated it by like from a particular index, and they are just giving that index name as pivot. So this was the original array, and after rotation the array would look something like this: 2 3 4 and then 0 1. So this was the original array, and this was array after rotation. So we need to find a target element if it is present in this rotated sorted array, and if it is present we need to return the index, otherwise we need to return -1, and we need to complete this entire solution in big O of log and time complexity. And let us see now with the help of this first example how we can find some solution out of it, and then we will see the code as well. So this is the first example, and this is the array nums that is being given to us, and target is 0. So we need to find the index of this 0th element of this value 0 in this nums array, and if it is not present then we need to return -1. And since the question has asked us to do this in time complexity of big O of log n, we need to write a solution which passes this case as well. So how we can solve this question? So there is a very big hint given in the question that the array nums was initially sorted, and we need to do this in big O of log n. Now do you remember any algorithm which runs in sorted array and its time complexity is big O of log n? Yes, it is binary search. So we will apply binary search in this question. So let us see how we can apply binary search algorithm in this particular question, because we know it is not actually sorted, it is rotated by some number of times. So let us see how we can apply binary search here. So initially what we tend to do in binary search, we first initialize low pointer, mid pointer and high pointer. So low would be pointing to the 0th element, high would be pointing to end element, and mid would be middle of both the low and high. So let me just name this index 0 1 2 3 4 5 and 6. So mid in this case will be low plus high divided by 2. So mid will be nothing but 6 by 2, that is 3. So initially our mid would be pointing to 3. So let me just erase this. So yeah, initially our mid is here. Now what is the most important thing in the binary search algorithm? In binary search we tend to eliminate one half, either from low to mid or mid to high. We tend to eliminate one half. Now in this case, since the array is not sorted, how we can say that we will eliminate a particular half? Now we will check both the pointer with the mid value. So nums of low is what it is 4. Nums of mid is 7, and nums of high is 2. So we will compare low and high with mid. So we can see that 4 is nums of low and 7 is nums of mid. So we can see that nums of low is lesser than nums of mid. So can we say that this particular part is sorted? Yes, definitely. So this is the most important condition. We can for sure say that either from low to mid or mid to high, one part will always be in sorted format. That is for sure. You can check that out with trying some different example. You will get to know how these things actually work. So we can say that yes, from low to mid it is sorted half. So we will check if this particular target element is present in this sorted half or not. Now why we are seeing that? Because we know we can easily now compare. So this part is sorted, so we can say that okay, if either this will this element 0 will be present in this sorted half or it will not be present. So let us see. So the minimum value in the sorted part is 4 and the maximum value in the sorted part is 7. So 0 is lesser than 4 and lesser than 7 as well, but the minimum value is 4. So we can for sure say that our zeroth element 0 will surely not be present in this particular part, because this part is sorted and the minimum value is 4. So that means we now need to eliminate this particular part and move our low pointer to mid plus 1 and then search in that particular half. So let me just erase it and draw it one more time so that you can clearly understand this. Now scenario would look something like this. Now again we will find the mid value. Mid value will be nothing but it will be 4 plus 6 divided by 2. So it will be coming 5. So our mid pointer would be pointing to index 5. Now again we will check the same condition, whether this which part is sorted. So first we will check nums of low is lesser than or equal to nums of mid. Nums of mid actually. Or nums of mid is less than equal to nums of high. So in this case both the halves are sorted. So this is also sorted and this is also sorted. So I have said that at least one will be sorted. There can be a possible scenario that both are sorted. So in this case both are sorted. So we will check our target element first. Let's say we check in this particular half, and then if it is not present then we will check in this half. So we will check our nums of low value is 0 and nums of mid value is 1. So we will check whether it can be present, whether this target value is lying between this nums of low or nums and mid or not. So we will check whether nums of low is less than equal to target and let me just move it down a little bit. Yes, and target is less than equal to nums of mid. So this condition says that whether our target value lies between low to mid or not. If it is, that means we need to search in that particular half. Else we will move on to the next half by eliminating this half. So let us check. So low is 0, mid is 1 and our target is 0. So yes, this condition gets fulfilled since our low is also 0 and target is also 0. So now we will move high to mid minus 1. So let me just redraw this entire scenario so that you can understand more clearly, and then we will proceed further. So this is the scenario after eliminating the second half, and our low pointer would be pointing to 0, high pointer would also be pointing to 0, so for sure mid pointer will also be pointing to 0. And now you can see that nums of mid is equal to target. That means if this scenario happens, then we need to return mid as our index, because that index is nothing but the index of our target element. So this is the scenario, and since this condition hits, we will return 4 from here. So this is how this particular scenario would look like, and let us see and understand in more better way with the code. And you can also check that the output here as well is giving 4 only. So yes, our answer also matches. So let us see the code now. So first of all, what we will do, we will initialize the low pointer and high pointer, and we will run the entire iteration till low is less than equal to high. Now first we are calculating mid. After that, what we have seen, we will first check which side is the sorted half. So how we have seen, we were comparing low with mid and mid with high. So first we will see whether nums of low is less than or equal to nums of mid. If this condition hits, that means this is the sorted half. Otherwise the other condition will follow, that is the other half is sorted. So if this part is sorted, what we will do, we will try to find target element in this particular sorted half. So we will check whether nums of low and nums of mid, target is in between them or not. So we are checking this condition. So whether target is less than equal to nums of mid, as well as target is less than equal to nums of low. So if this is happening, that means we need to move our high pointer to mid -1. If this is not happening, then we will move low to mid +1. And this is the same scenario, but just in the other half. So we will replace the low with high, and the same thing will follow. And in the end, if we get an element which is nums of mid is becoming equal to target, then we will return mid. So this will be the index of the target element. So target element's index will be returned from here. And if this particular condition never happens, then we will return -1, because then this loop will get over and we will automatically be returning -1, since we get no target element. So this was all about this question. So I hope you understand this part. Thank you.